So while I'm giving people a chance to join, are there any questions that have come up between when we met on Tuesday and today?
Yeah. So I was watching your videos,
Mm-hmm.
how to do the note sheet and whatnot.
Mm-hmm.
And you kept referencing the answer key, and I could not find the answer key.
The answer key.
I'm just like, well, and then in my problems that I was doing, I kind of made like two solutions to almost every problem, and I'm just like, well, it's either this one or this one. I'm not sure what it is.
Are you talking about the homework or
Yeah.
the note pages?
Not the note pages.
Yes, it
I
looks
know in
like
the video.
they didn't get uploaded for 1.1 through 1.4. So I'll get those uploaded today.
Okay.
Normally, they would be listed underneath the submission folder. And yeah, it looks like they didn't get loaded. So I will get that done today. Thanks for letting me know, Sophie.
Mhm.
I have a question.
Mm-hmm.
So with every homework assignments we have to turn in the notes with it too, right?
So that's a good question. So there's two things, right? We have our note pages that we're doing that have to do with the lecture, and then you have your homework. And with your homework, I ask that you record your written work as you're doing the homework and upload that. And so when you're clicking on the submission folder to get to the digital homework assignment, that's the same submission folder you would use to upload a copy of your written work for the homework.
Okay.
Does that make sense?
Yeah. Thank
Yeah.
you.
And the only reason, again, the reason I ask is that if you are going through the homework and you keep getting one problem, like a certain problem wrong, and I would encourage you to email me and say, hey, will you check my work against what the computer says the answer is? Because it's just possible that you're putting it in different than the computer anticipates it should be put in, and therefore it's marking it wrong, even though it shouldn't be marked wrong. Do you know what I'm saying? So it gives me an idea of like what you think it should be and what you're intending, and then versus what the dumb Android thinks it should be. Trying to put the two together. So that's why I mean, obviously, if you got 100% on your homework, you don't have to upload your written work if you don't want to, right? But it's there so that you can, I can then check against the two things, right? And then to speak about homework as well, I do go in and review the solutions for that same reason to see if anybody got something wrong that they shouldn't have gotten wrong because the homework, like the computer marked them wrong. But I don't review them until after the due date so that like everybody has gotten their stuff in, so I can just sit down and do it all at once versus like going in individually. But as I said before, you get 3 chances on a homework assignment, and it'll have you go through and do the whole homework assignment the first time, and then it'll have you go back and really do the problems again that you got wrong. And then you could do it a 3rd time, and again, just focus on those problems that you get wrong. So it won't let you go back and do the whole assignment again. If you wanted extra practice, then I would encourage you to do problems out of the textbook. And with the textbook, the answers to the even problems are in the back of the textbook. So like if you're looking for more practice, that's where you can find more problems. And then obviously the answers to make sure you're doing the problem correctly. More questions, these are great.
For the people that didn't get like a physical textbook and you go to the bookstore and you get your book, what if they didn't give you a book? What if they give you like a code for something?
You shouldn't have a code.
Okay, because
So
they
they
gave me
like an Edfinity code.
envelope.
Yeah, you take that back. Because we're not using
Okay.
that in this class. So you just need the textbook. There's been so many cross wires. All you need is the textbook. They may even have some for rent in, I mean, I know that you might be able to rent them from the bookstore themselves, But yeah, you only need the textbook. You don't need that code. So return
Okay.
that and get your money back. And then get the textbook.
Okay.
Yeah, so it should
Okay.
look like this. The textbook you want looks like this.
Yeah.
Yeah.
Yeah. They gave me
That's-
like a little like envelope with a code, and I'm like,
Right.
okay.
Yeah, no, take that back. They're confused.
Okay.
So I don't know if they're confusing because it's my name. I teach 2 different math for healthcare classes. One is Math 120 and one is Math 140. And the Math 140 uses the code that you're talking about, and Math 120, which you're in, does not use the code. So that could be why they're like, oh, it's Aaron, we'll give them everything. And no,
Yeah,
take the code
I think
back.
they did that.
Any other questions? Okay, well, let's jump into the material. So throughout the lecture, I will have the chat box up so I can see if you want to send me a direct message. If you have a question, feel free to unmute yourself and ask the question as well. You know, there's no need to raise your hand or anything, just interrupt me. It's no big deal. And so I use a program that mirrors my iPad to my laptop because my laptop is not an Apple product. And sometimes it shorts out. So if like the screen just goes black or goes back to me, that just means I have to sit and resync them, but it should only take a few minutes. So Roman numerals. Why do we talk about Roman numerals? Because Roman numerals are used a lot in the medical field, especially when it comes to medications and prescription orders, as well as how the medications themselves are measured. And so we do need to talk about Roman numerals. And so we've got the basic breakdown here in the box. So then the number 1/2 is represented with 2 lowercase s's. You have to have the 2 s's together. It's not like if you have 1 s, that means a quarter. Like think of the ss as like one little thing. It's all together. You can't break them up. So SS represents 1/2. Capital V or lowercase v is 5. Capital I or lowercase I is the number 1. Capital X lowercase x is the number 10. Capital L is the number 50. Capital C is the number 100. Capital D is the number 500. And capital M is the number 1000. And so we can build all of our numbers that we use in our Arabic counting numbers, which is what it's referred to, or Hindu Arabic numerals, excuse me. We can build all of our numbers based upon just those, 8 characters. And so when we write Roman numerals, they're written in descending order. In order to convert a Roman numeral to a Hindu Arabic numeral, which is our counting system, we convert the numerals and then add them together. We'll come back to that because we're going to first focus on, oh wait, no, we are going to do that first. I'm always going the other way in my brain. When writing Hindu Arabic numerals as Roman numerals, you were limited to 3 of the same value in a row. For example, the number 9 is a Roman numeral, and we write it as IX, not VIII. So you can't put 4 of something in a row. So once you hit 3 of something, when it's time to keep going, you then move it to before the next largest one. And I'll explain what that looks like. And when you're writing these, think about breaking the number up by place value. The letters L, V, and D cannot be repeated, or else the number is considered invalid. And when I, X, and C are written to the left, they're subtracted. We cannot subtract V, L, D, and M. Looks like I have an error there. Ignore that. So
I have a question
yes,
already. We haven't even started.
that's okay.
So when it says written to the left, is it comparing the number that's bigger to it next to it?
Yes. So like if I write V to the left of I, well, V is greater than I. So I'm not subtracting 5 from 1. But if I write an I to the left of V, I represents 1 and writing it to the left of V because it's less than the V, then we are subtracting that. So you're
Right,
looking at
'cause
the
you-
number that it's directly next to see if you're subtracting it or not.
Because you can't have like a negative solution.
Correct. So if we, before I get into this, I think it'd be helpful. Did I write that? I have that in. I'm gonna go the other way. I think it's helpful if we take our numbers that we normally deal with and write them as Roman, and then go back to taking Roman numerals and writing them as our Hindu Arabic ones. Let me see if let's go to the next page. So it says, write the following Hindu Arabic numerals as Roman numerals. So I have the number 8. Now remember, if I write what I've got, we have SS, which equals 1/2, I, which equals the number 1, V, which equals the number 5, X equals the number 10. What do I got after that? L, which equals the number 50, C, which equals the number 100, D equals 500, and M equals 1000. So if we think about the number 8, we can break up. And when we're looking at breaking it up, we're always looking at breaking it up using those pieces that we have, meaning the number 8 is equal to 5 plus 3, right? And the reason I broke it up into 5 plus 3 is because I've got those building blocks of 5 right here and I, meaning the number 1. So I can break up the number 5, I can represent that with V. And the number 3 is 1 plus 1 plus 1, which I would write as I. Therefore, the number 8, we would write as a Roman numeral as V, I. We can't subtract more than 1. I get this question a lot of like, well, but 8 is just 2 less than 10. Why can't I write IIX? And it's because we can only subtract one value from another value. So if we think about our counting numbers, we have the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm just going to go through 18. But if we write their equivalency in Roman numerals, the number 1 is just I. The number 2 is 1 plus 1, right? That's how we would create the number 2. Therefore, we're going to write I. The number 3 is 1 plus 1 plus 1. So I. The number 4 would be 4 ones added in a row, but we have to remember our rule says that we cannot repeat a value more than 3 times. So at this point, we now need to think about subtracting. And so we would think of the number 4 as being 1 less than 5, and we would write that as IV. Then number 5 is V. The number 6 is 5 plus 1, so we'd write V1 or VI. The number 7 is 5 plus 2, so we have V and then 2 I's. The number 8, as we already said on the left here, is V plus 3 I's. And now we've reached a point where we've used 3 I's in a row again. To get to the number 9, a lot of people want to write V and then 4 I's, right? But we can't write 4 I's in a row because we can't have 4 of a number. So then we move to subtracting 1 from the next place value, which is from 10. So we have IX. Then 10 is X, 11 is XI, 12 is XII, 13 XII, and then does anybody want to take a guess of what 14 is? So if we want to break this up, the number 14, what two numbers add together to be 14? Right? We can think of 14 as being 10 plus 4. And I use the number 10 because 10 is one of those building blocks we have, right? It's X. We already know the number 4 is IV, therefore the number 14 we would write as XIV. Number 15 is going to be XV. Number 16 is going to be XVI. And again, you can see how we're breaking these up into these pieces, thinking about that as place values. We have a tens position and then the ones position where those sixes are. We already know that 6 is VI. 17 is XVII. 18 is XVIII. And then I want you to make a prediction about what 19 is and send it to me in a direct message, please. All right, nice job. So if we think about this, the number 19 would be like 10 plus 9, right? Well, the number 10 is X, and the number 9 is, as we know from over here, IX. Therefore, the number 19 is XIX. All right, so we've got bigger numbers, right? We can't unfortunately just stick with those 1 through 20s. Unfortunately, we got to get bigger. So if we look at the number 49, how does that relate to the values that I have listed above? So it's like 50 minus 1, right? I mean, what? But if we look at our notes on the previous page, it says we cannot subtract within, and I don't think it didn't make it in there. Yeah, it didn't. Okay, so I saw, so the box got cut off. One thing we need to keep in mind is that the numbers that are subtracted have to be within 10% of what they're being subtracted from. So here's what that means. The number 50, if I compare the number 1 to that, 10% of 50 is 5. So the most I could take away from 50 is 5. Because 1 is less than that, we have to come up with a different way to represent that. Okay, so you can't just take 1 from 50. So the number 49, how is another way we can think of this? Well, we can think of this as 40 plus 9, not 90, just 40 plus 9. So 40, that is 50 minus 10. 50 minus 10, in order to represent that, we would put the 10 before the 50. And then the 9 is going to be 10 minus 1, or IX. So 49 is XLIX. And you can also write that with an uppercase I. When to use the uppercase I is numbers that are greater than 10. But if you use a lowercase I, that's also okay. Just that's how you want to think about when to use the upper versus the lower. Okay. So 49 is kind of a crazy one. Any questions about that one? Okay. So if we look at the number 95, what do we think about that one? So what number is 95 close to? What do we think?
100.
It's close to 100, right? So how far off of 100 is it though? It's 5 off, right? But we have that rule of the 10%. We can only take numbers away that are within 10% of the number. So we can't take 100 and minus 5. That's not allowed, okay? But what we can do is do 100 minus 10 and then add 5, because 10 is 10% of 100. So if we look at 95, I want to represent the 100 minus 10, and remember to represent subtraction. We bring the letter before, so that's going to be XC, because 100 is C. Bringing the X before it means we're subtracting, and then we'll add the 5 on, so we get XCV. When thinking about how to write these out, we want to focus on using the least number of Roman numerals possible, as long as we are also still satisfying the rule of the 10% rule, okay? So before I do number 4, I want you to try number 5 and send it to me in a direct message. Okay, so think about the number 24. 24 is going to be 20, or it's 24.5, right? So 20 plus 4 plus 0.5. If we're breaking it up into the pieces, 20 is going to be XX, 4 is going to be IV, and then 0.5 is SS, which gives us XXIVSS. And if you can, I know it's really hard, especially with our handwriting, the S's should be lowercase, right? So we want to try to indicate that they're lowercase, just to let you, as you're writing it out, I would try to, but obviously we do the best that we can. All right, thinking about number 4, how could we break this up? As you see how I wrote right here, what I mean by breaking it up, breaking up the pieces that could add together, I want you to try thinking about how would we break this up? What would be the pieces you would break it up into?
By place value.
Okay, so we think about place value. We've got 1,000 plus 400 plus 70 plus 4, right? So 1,000, we have a Roman numeral exactly for 1,000. That's the number, or the letter M, excuse me. 400. Well, 400, we would think, okay, well, that's 4 hundreds together. But remember, that's 4 in a row, which we can't have. So we have to do 3 of them And then after we do 3, then we think, oh, we have to subtract. So C and D, C is 100, D is 500. We would want to subtract 100 from 500 to get that 400. So we'd have MCD, because that's what equals 400. 70 is going to be 50 plus 20, so LXX. And then the number 4, as we know, is IV. So when you start getting into larger numbers, they get longer, okay? And so so if we think about, again, the pieces of this, 400 is equal to 500 minus 100, which is why we're going to take that D and put the C in front of it, because we're taking that 100 off. So I want us to go back to the first page, and we're going to interpret the Roman numerals and write the Hindu Arabic ones that are equivalent to it. So we already have number 1. I'll have us skip that because we know that that is the number 8. I want you to try number 2, and I'll pull this down so you can see the numbers up above. I want you to try number 2 and send me your answer in a direct message. So if we take number 2 and we break it up, we know that X equals 10, V equals 5, and the SS equals 0.5. So the fact that we have XX, that gives us 20, V is 5, and then SS is 0.5. Because there aren't any Roman numerals that are to the left of something that's larger than them, we can just add all of this together, giving us 25.5. All right, I want you to go ahead and try 3 and 4 and send those to me in direct message. Let me know if you need me to, well, I'll just write them here so we don't have to have it blown up so much.
Wait, we're doing 5 and which one?
Just 3 and 4. Going straight first, yeah. Okay, so number 3, XXIX is gonna have us 29. Number 4, LXX, this whole piece right here makes 80. And then plus the 9 gives us 89. I'm gonna let you do 5 and 6 on your own. And then I will get the solution sheet uploaded today. And you can check your answers against that later today. Katie, I see your question there, and I think this is a good one to ask with everyone. So when you're writing the Hindu Arabic number of SS, it doesn't matter if you put a 0.5 or a 1/2, either of those are acceptable. I tried to adjust to make sure that Eagle Online wouldn't mark you wrong for both. But if you do get a situation where you're using one over another and it is marking you wrong, then I would suggest using the 0.5 instead of the 1/2, because it might not be reading your fraction properly, okay? All right, let's go to the next page, talk about ins and outs. This section, these first couple sections, they kind of jump around in content, and it's because they're trying to cover a bunch of little things that they want you to have in mind as we're moving into the regular content. So ins and outs, this idea that 1 cc and it's 1 cubic centimeter equals 1 milliliter. That relationship is true. And then, and that's true for all liquids. And then we have some standard measurements. Obviously, if you are in the medical field and you are trying to figure out how much fluid a patient took in, they might have some different conversions or equivalencies that you would be using based upon the size of the serving of coffee or Jello or whatever else you're giving the patient. But these are the standard measurements we're going to use unless otherwise indicated. So 1 ounce is equal to 30 cc's. A carton of milk is 240 cc's. A carton of juice is 120. 1 cup of Jello is 120. 1 bowl of soup is 150. 1 serving of ice cream or sherbet is 120. 1 popsicle is 90. If a measurement doesn't fit the standard measurements, then you're going to use, again, that 1 ounce equals 30 cc's to convert the measurement to cc's. So if we go to the next page, it says, determine the patient's intake if they consumed the following. So we have 1 carton of milk, which we know from the previous page is equal to, 1 carton of milk is 240. Is that what we have? Yep, 240. 2 bowls of soup. So 1 bowl of soup is going to be 150. 2 cups of coffee, and they're 8 ounces each. A serving of ice cream, which is 120. A cup of Jello, which is 120, and a carton of juice, which is also 120. And we want to know the patient's intake. So when we think about what they consume, they're adding all of this up, right? The piece that I don't have written here is the 2 cups of 8 ounces each of coffee. Now you'll notice the rest of this stuff is in cc's, but the coffee is not. So if you think about adding this up, we're going to first take our 8 ounces of coffee, we're going to multiply it by 30 in order to convert those ounces to cc's. And so 8 times 30 is going to be 240 cc's. So we've got 2 cups each of those 8 ounces, so we're gonna have 2 times the 240. So from here, we can just add this all up. So we have 240 plus 2 times the 150 plus 2 times the 240 plus 120 plus 120 plus 120. So again, we're just at this point calculating the intake of fluid for this patient, and then in the next part, we're going to look at what the output is to determine if there's an overall gain or loss of fluid. So we add these up. What do we get? I don't have a calculator in front of me.
$1,380 cc's.
1380. We all, is that something that we all got? Yep. Okay. 1,380 cc's. Great. So suppose the patient had the following urine outputs: 350, 300, 325, 250, 300, and 200. Is there an overall loss or gain of fluid? So in order to calculate the overall loss and gain, we first have to calculate the output. So we're going to take 350 plus 300 plus 325 plus 250 plus 300 plus 200. And I have 1,725. Do we get the same amount? Yes. Okay. So the overall gain or loss. When calculating this, you're going to take the intake and subtract the output. You always want to do it in that order, because if you get a negative answer, that indicates a loss of fluid, meaning they are losing more fluid than they're taking in. They're experiencing a diuretic situation. Versus if you get a positive answer, then they have a gain of fluid, therefore they're not voiding as much as they're taking in. So our intake is 1,380 cc's. Their output is 1,725 cc's. Therefore, we have a difference of, what is this, a negative 3, what do we got? I don't have the answer to that one written down, so I don't have it in front of me. 345? 345? Okay. So we have a loss of 345 cc's of fluid, which, I mean, is not necessarily like something that we have to be upset about. They could already be, retaining fluid, so we want them to have a loss of fluid. Who knows? But in this situation, we just need to know, what is their fluid imbalance, right? Is it a gain or a loss? Or if you get an answer of neutral, of 0, they've neither gained nor lost. It's a neutral exchange. So find the total fluid imbalance given the following. Intake is a 4-ounce cup of Jello, 6 ounces of water, 5-ounce bowl of soup. Outputs are 100 cc's, 250 cc's, and 150 cc's. I can tell you right now, because the way that these are measured, these are not under the standard measurement. So we want to use that 1 ounce equals 30 cc's conversion first. We can't use our standard equivalencies that we have on the previous page. So why don't you go ahead and calculate that one and send me your answer in a direct message. All I'm looking for is the final answer, the difference between the intake and the output. So if we look at the calculating the total intake, we're gonna have 4 times 30. I have the hardest time writing 3s with my eye pencil. I don't know why. 6 times 30 plus 5 times 30. So 4 times 30 is 120 cc's, 6 times 30 is 180 cc's, and 5 times 30 is 150 cc's. So when we add these all up, we have a total intake of, we got 450. And then the outputs it's going to be 100 plus 250 plus 150, which gives us 500 cc's. So the change is, remember, always your intake first minus your output. Therefore, we have a loss of 50 cc's of fluid. Okay, so like I said, we jump around in this first section a lot. So we're going to go to fractions next. We will be using fractions a lot. And so we've got some definitions for fractions. We've got a proper fraction, which is a number less than 1, written as a ratio. And a ratio is just A over B, right? It's literally just what we think of a fraction as. And fractions are just division problems written like that bar means division, means the numerator being divided by the denominator. And the numerator must be smaller than the denominator in order for it to be a proper fraction. An improper fraction is a number that's greater than 1, written as a numerator, or excuse me, written as a ratio. The numerator is larger than the denominator. So 3/2 would be an improper fraction, right? We can have a mixed number, which is a number consisting of a whole number and a fraction, like 1 1/5. When reducing fractions, you want to find the greatest common factor, which is the largest factor of 2 numbers. That's what's going to allow you to reduce that fraction. And then to reduce a fraction, you're going to find the greatest common factor of the numerator and the denominator, and then divide the numerator and denominator by that value. To convert from an improper fraction to a mixed number, divide the numerator by the denominator and the quotient. And all I mean by the quotient is however many times that denominator goes into the numerator will be your whole number. And then you've got the remainder written over the original denominator, which represents the fractional portion of the mixed number. It's always funny to me when you try to write out how to solve the process, it ends up sounding more complicated than it is. So if we look at number 1, 21/6, it says convert between proper and improper fractions. Again, this is an improper fraction. We want to write it as a mixed number. So we're going to take 21 and divide it by 6. Well, 6 goes into 21 3 times, because 6 times 3 is 18. We subtract these. 21 minus 18 is going to be 3. And so we have this is the quotient, this piece right here. That's the quotient. And that's going to be our whole number. So we have 21/6. We would write as 3 3/6. You always want to reduce your fraction portion if you can. If we think about the greatest common divisor of 3 and 6, the largest number that divides into both of those is the number 3. If I divide 3 by 3, I get 1, and divide by 6 by 3, I get 2. And then we end up with 3 1/2 as our mixed number equivalency. If you have a hard time with reducing these numbers, if we take our 3/6 and you're like, again, how did I get that 1/2? Remember, we can write this as 3 times 1 over 3 times 2, right? Breaking that down, and we can see how that factor of 3 is brought out, giving us 1/2 as its equivalency. Okay. If we're converting between a mixed number and an improper fraction, you're going to take the whole number and multiply it by the denominator. So 4 times 3. And then you're going to add the numerator and then place the resulting value over the denominator. So 4 times 3 is 12. 12 plus 3 is 15. So the equivalent improper fraction is 15/4. So why don't you try numbers 2 and 4 and send me your answers in a direct message. So number 2, we're going to do 27 divided by 8. 8 goes into 27 3 times, because 8 times 3 is 24. Subtract those and we get a remainder of 3. So we end up with 3 3/8. And number 4, we're going to take 5 times 2 and then add the 3, placing it back over the denominator. 5 times 2 is 10 plus 3 gives us 13/5. All right, next page. Nope, just kidding. Dropping down to the explanation at the bottom of least common denominator. So we talked about the least common denominator because we're going to need to add and subtract fractions. And so the least common denominator is the smallest number that is a factor of both the divisors or the denominators. We think about equivalent fractions. 2 fractions are equivalent if they represent the same numerical value. So all they're trying to say is that if I had the number 1/2, an equivalent fraction to that would be like 2/4, right? They mean the same thing. If I took 2/4 and I reduced it, I would get 1/2. The explanation for how to create equivalent fractions is you're going to multiply both the numerator and the denominator by the same number, and the resulting fraction is equivalent. Or you can divide the numerator and the denominator by the same number and get a reduced fraction that's equivalent as well. And then in order to compare fractions, you need to identify the least common denominator of the fractions you want to compare, then convert the fractions that you want to compare to equivalent fractions, and then compare. So many words. Why? What do they mean by this? So if we look at the next page, we've got the numbers 3/4, 2/3, and 1/6. And it says find the LCD, meaning the least common denominator. So the smallest number that 4, 3, and 6 all go into would be 12. And the reason we know that is if we take our factors of each and we write them out, we would be able to identify the smallest number that exists in both lists. So if we look along this list, we can see the smallest number that's common to all 3 lists would be 12. So the LCD is 12. Now, if I wanted to compare these fractions in order to identify which is the larger one, we might already have like a gut reaction as to which one we think is the largest, but it's helpful to compare them in order to know for sure. So if I want to turn 3/4 into a fraction with 12 as the denominator, in order to get 4 to turn into 12, I need to multiply by 3, which means to get the 3 to turn into its equivalency, we need to also multiply by 3, which gives us 9/12. For 2/3, to turn into a fraction with 12 as a denominator, I have to multiply by 4. So again, we have to do the same to the numerator, which gives us 8/12. And then 1/6, I had to multiply by 2, which again, doing the same to the numerator, gives us 2/12. So 3/4, 2/3, and 1/6 is really 9/12, 8/12, and 2/12. If we were asking which fraction was the largest, we'd be able to identify that 9/12 is the largest because again, our denominators are all the same now. We can look at the numerator. Because 9/12 is the largest, that tells us also that 3/4 or 3/4 is the largest of those three fractions. So that's what they meant on the previous page about how you would compare the fractions to each other. So adding and subtracting fractions. In order to add or subtract fractions, the fractions must have the same denominator. If the fractions do not have the same denominator, we need to identify the least common denominator and write the equivalent fractions with the new least common denominator. Again, what I was doing here was creating fractions with the same common denominator. So before I talk about multiplying and dividing, let's just focus on adding and subtracting. So if I have 2/3 and 3/4, again, I need to add these together. They need to have a common denominator. We already know from the past example that the smallest number that both 3 and 4 divide into is 12. So the least common denominator is going to be 12. So I can take 2/3 and I can multiply it by 4/4. And I can take 3/4 and multiply it by 3/3. 4 times 2 is 8. 4 times 3 is 12. This is the whole point of us doing this. 3 times 3 is 9. 4 times 3 is 12. So 8/12 plus 9/12 gives us 17/12. And you can leave that as an improper fraction. You only have to convert it if the instructions say to convert it to a mixed number. If we wanted to write this as a mixed number, we could say, well, 12 goes into 17 once with a remainder of 5, so giving us 1 and 5/12. So I want you to try number 2 and send me your answer in a direct message. Okay, so let's think about these numbers, 21 and 14. We could list out the common, list out the multiples of these. So we have 21, 42, 63, 84, 105, and we could keep going with 21. Look at 14, we've got 14, 28, 42, 56, and then what, 70, I think, yep, 84. So eventually we can see that there is more than one common factor for both of them, right? But the smallest one is going to be 42. So for 21, 42 is equal to 2 times 21. And for 14, 42 is equal to 3 times 14. So if I take my first fraction, 2 over 21, and I multiply both the numerator and denominator by 2, I end up with 4 over 42. If I take 3/14, I can multiply both the numerator and denominator by 3, giving me 9 over 42. So adding these together, I end up with 13 over 42. So if you don't want to go through listing out the multiples of them, we can think about the factorization of these numbers. 21 is equal to 3 times 7, right? And 14 is equal to 2 times 7. So the number that's common to both those lists is 7, right? So if we look at what numbers we would need to have to create a factor that both of those are going to go into, we would need to have a 2, a 3, and a 7. If we multiply all of those together, this gives me 6 times 7, and that gives me 42. And so that would give me that number right away that would be the smallest number that's going to have all of those factors in it. If you're uncomfortable with that process, that's totally okay. You can just use the listing out of the multiples, but using the factorization is going to be a faster way to do it. So in number 3, we want to do subtraction, right? So we need to find the common denominator there. And so we already have one fraction with a denominator of 12. Therefore, and we know that 4 is a factor of 12. So we can just take our left fraction, multiply both the numerator and the denominator by 3. We don't have to do anything to the right fraction. 3 times 3 is 9 over 12. Subtracting those, we end up with 4/12. But obviously, because we know that 12 is divisible by 4, we want to then reduce. So we can divide the numerator by 4, the denominator by 4, giving us 1/3 as our final answer. In number 4, we can see we have mixed numbers. So some teachers will show you the vertical method. If you took Math 65 before this class, you might have learned the vertical method. It's not my favorite method personally, because especially when you're subtracting a denominator fraction that's larger than the numerator fraction, it creates this weird thing of borrowing. So I tell students, just switch both of those mixed numbers into improper fractions and then deal with them. So I'm going to do 3 times 5, which is 15, plus 1 is 16. And the second one, I'm going to do 3 times 3, which is 9, plus 2 is 11. And then we have 2 nice fractions that we can just subtract from each other. And in this case, they already have the same denominator. So 16 minus 11 is going to be 5/3. And we can switch this back into a mixed number, giving us 1 and 2/3. I'm going to let you do numbers 5 and 6 on your own and then go back and check them. But we're starting to run short on time, so I'm going to go to the next page so we can talk about multiplying and dividing fractions, okay? So when we multiply and divide fractions, For multiplication, you're just going to go straight across the top and straight across the bottom. Now we have an option to reduce then multiply, or multiply then reduce. So in number 7, if we were to just do the multiplication, straight across the top is going to give us 15, straight across the bottom is going to give us 60. 15/60 is not in reduced form. There are common factors that go into both 15 and 60. And so we would have to now reduce this. Now the greatest common factor for both of these is 15. So if I divide my numerator by 5 and my denominator by 5, I get 1/4. I often get asked the question, well, how did you know to go to 15? What if I'm not comfortable with going to 15 right off the bat, like recognizing that that is the common factor I need to divide by? We can look at 15 and 16 and go, oh, well, one ends in a 5 and one ends in a 0, so they're both divisible by 5. So you can always start with a smaller building block of what you recognize goes into both, and you'll eventually get to that most reduced form. So the first way in purple is an example of multiplying then reducing. The alternative is reduce then multiply. Now, this reduction technique is only allowed because we're dealing with multiplication. Don't do this if you have addition, right? It's only because we have multiplication there that we are able to do this. So looking here, I can recognize that I've got a 5 in one denominator and a 5 in one numerator. Because when we think about multiplying fractions, it's everything on the long top multiplied together over everything on the bottom, which means we're really doing the numerators divided by the denominators. And since I have a 5 present in the numerator and a 5 present in the denominator, together they make a factor of 1, and we can cancel those out. We also know that 3 goes into 12. So 3 is going to go to itself once, and 3 goes into 12 4 times. So these fractions just kind of fall apart, meaning we get 1/1 times 1/4, which reduces to 1/4. And so that's where we could reduce then multiply. And if you can see where you can reduce, I prefer to reduce first before multiplying, because then you're dealing with smaller numbers, okay? And you're not going to have to try to divide so many times. With number 8, as you can see, we've got a fraction times a mixed number. Again, you want to take that mixed number and turn it into an improper fraction. So we would have 2/3, and then the mixed number is going to be 4 times 2, which is 8, plus 3 is 11. So we'd have 2/3 times 11/4. So once we convert that, then we can multiply through as we would. Jumping down to number 9, again, you can just go ahead and finish number 8 on your own after we're done. Number 9, when we are dividing a fraction by another fraction, you're going to leave the first fraction as it is, and then we're going to take the second fraction, we're going to flip it, and then we change that division to multiplication. So only the second fraction flips, okay? So, and then from here, we can just do straight multiplication as we were doing. This is, again, a good example of a problem where it would be helpful to reduce then multiply, because we can see that 3 goes into 9 and 2 goes into 8 if we're looking diagonally from each other. Number 10 looks weird. It looks like what we refer to as a complex fraction. But remember, fractions are just division problems. So what this is telling us is 2/3 divided by 5/6, because the 5/6 is in the denominator. So we're just taking that numerator, the fraction in the top, dividing by the fraction in the bottom. And again, with that division, we're going to take that second fraction and flip it, and then change it to multiplication. So any questions about 8, 9, or 10? Obviously, at this point, you would be able to finish all of those. Okay. So the last thing I want to talk about is converting between fractions, decimals, and percents. So a percent means parts per 100. So to change a fraction or percent to a fraction, you're going to drop the percent sign and put the number over 100, and then reduce. So we need to add in there, reduce if possible. Changing a fraction to a percent, we're gonna divide the numerator by the denominator to change that fraction into a decimal. And then we'll move the decimal point in the result 2 places to the right and then add a percent symbol. So if I'm looking, what I'm talking about here is if I have something like 1/4, I'm going to take 1 and divide it by 4. Because 1 is less than 4, we have to add a decimal point and a 0 in order to create that division. So now 4 goes into 10 2 times. Subtracting, and I didn't give myself enough room. Let's go down here. Four times 2 is 8. Subtract is 2. We're going to bring another 0 down. So 4 goes into 25 times. And the subtraction is 0. So then we end up with 0.25. The next step is to move that decimal point 2 places to the right. So if we move that 2 places to the right, we're going to go once, twice, which gives us 25, and then we add the percent symbol on the end. So that would be our process from changing it from a fraction to a percent, which obviously we went from fraction to decimal already. To change a percent to a decimal, you're just going to go the opposite way, moving your decimal point to the left. So if I have 37%, all I'm going to do is take this decimal point at the end and move it 2 spaces to the left, giving me 0.37. So in this table, I want you to write the equivalency between these two. So between the fraction, decimal, and percent. So if we're going from 2/5 to a decimal, we're going to take 2/5, which means we're going to take 2 and divide it by 5. Again, 5 can't go into 2, so we have to add a 0, which means we have to add a decimal point. 5 goes into 20 4 times. So 4 times 5 is 20. And when we subtract, we get a 0, so we've terminated, we're done. So the equivalent decimal to 2/5 is going to be 0.4. To change it to a percent, we're going to take 0.4. We have to move it 2 times. You can see that we have nothing left after the 4. So we need to add a 0. And then once you add that 0, you would add your percent symbol. So we would get 40%. Then I'll let you do the last 2 lines on your own. When we are done with lecture, I will get the solution key uploaded so that you can check your work against what I have written down, to make sure any of the problems that I told you to try on your own, that you know what the answer is supposed to be for those, right? Today's notes, when are they due? They are due the 20th, so tomorrow night. So anything you haven't finished today, you want to finish up tomorrow and get it uploaded by 11:59 p.m. The homework for this, for 1.1, 1.2, and 1.4, which is what I covered here today, all of that homework is going to be due January 25th, which is, what day of the week is that? That is next Wednesday. So I would encourage you to work on it between now and Wednesday, obviously. Any questions you have, bring them to lecture on Tuesday, and then we can go over them then, okay? So make sure you try them between now and then. I don't want you to wait till, the night before or even Wednesday to do all of the homework. I want to give you some opportunities to ask questions. So we did a lot today. That's one of our bigger lectures. I will tell you, over the course of the semester, we will have, most of our lectures will be shorter than that, or maybe not as much material covered as once. But a lot of this, they consider review. Obviously, the ins and outs stuff and the Roman numerals might not be considered review for you. But if you have questions about them, reread the textbook, look at the videos, the individual videos that I have uploaded. And then, as always, please email me. Okay. All right. Any questions for me before I let you go? Nope. All right. Well, I hope everybody has a good weekend and I will see you all on Tuesday. Bye, everyone.